Okay.
Good morning to all of you. Good morning to all of you. Welcome to the little refreshment, little break after 3 days. So now we are in the probability topic. Already Purushottam sir has given the complete details of basic concepts and category wise questions, tossing a coin, probability of head or tail while you are tossing a coin, single coin, two or twice, two coins, three coins, and probability of a upcoming number on the dice, and next probability of getting spade cards, and the basic concept of cards and what are the types of cards, how many cards will be there. That is the part which is given a small introduction and which is given a small assignment to you, if at all possible to you, then you go through the concept of those playing cards. So I hope that definitely every student will gone through that one. So if you gone through that one, then whatever the message will be given by our Purushottam sir will be very effective today for you. And go through the concepts of probability, playing cards, and after that he will go through the exercise questions. Purushottam sir, please go through the concept.
Thank you, sir. Good morning, children. Good morning to everyone. So after 3 days, now we are going to discuss third day of probability. So children, already I gave you a small task for you, which is that one is already I think you get some knowledge on playing cards. Once again, we will go through on playing cards. So here children, once again we will repeat. In the deck of cards, how many cards are there? Please recall. Yes children, a deck of playing cards, 52 cards are there. How many cards are there children? 52 cards are there. And which are divided into 4 suits. How many suits children? 4 suits. Each should contain 13 cards. Each should contain 13 cards, excluding joker. We don't consideration into joker. So here only 52 cards. How many cards are there? A deck of card means 52 cards. A deck of cards means total 52 cards. And these 52 cards divided into 4 suits. 1, 2, 3, 4 suits. And each suit means here each suit contains 13 cards, and they are, the first one is black spade. The shape is like this. See children, there are black spades and red hearts. Black spades, red hearts, and red diamonds. Red diamonds. These black spades are 13 cards. Red hearts also 13 cards. That they are in red in color. Red hearts red in color. Red diamond. This is red diamond. These are also 13 cards. So and black club. So black shapes are totally 13 plus 13, 26. And red total red colors 13 plus 13. Is also 26. So here now see children, black spade. Once again here this is one of the black spade. So king here king. This is only the shape is like this. Black spade shape is like this. Next one, red heart. The shape is like heart, which is in red in color. children, this is red in color. This is called the shape. This shape is called red heart. That also red in color. And now red diamond. Red diamond. Already we easily identify diamond shape. This is a diamond shape. See children here, diamond shape. And also now black club. Black club. So the shape is like this. This is a flower type, black club. Totally 4 suits are there. Totally, how many suits are there, children? 4 suits. Each suit contain 13 cards. So, it should contain 13 cards. So here, black spades are so 13, red hearts 13, red diamond 13, black club 13. So here, once again, here. See children here, the cards in each suit are, the first one is ace. Do you know about ace? Okay. We will see next what is ace. Already we saw king. Here ace. Ace, king, queen, jack, 10, 9, 8, 7, 6, 5, 4, 3 and 1. So these are the 13 cards in each suit. In each should contain one ace, king, one queen, one jack, 10, 9, 8, 7. Totally, these are 13. Each should contain 13 cards. So, here, once again, important point is there. Kings, queens, and jacks are face cards. Because already we saw king. King is a face card. These are called the face card. Face card. Kings, queens, and jacks. So please remember it, children. Kings, queens, and jacks are face cards. So here, children, here once again, we move into next one. Here once again, this is a black spade. This is black spade in ace. Is a red heart. Is a red heart. Please identify children. Please identify red diamond, black club in ace. In ace, black spade, red heart, red diamond, black club. Okay. Now, see children, one suit of 13 cards. See children here, one suit of 13 cards. So here, ace, 2, 3, 4, 5, 6, 7, 8, 9. This is 10, J, Q, K. Like this. One suit, 13 cards. These are. In another color, 13 cards are also there. In another color, 13 are. So, black color, 26. Red in color, 26. So, each suit, 13 cards. Shapes. Each suit, 13 cards. Black spade also, 13. And red horse, 13. And red diamonds, 13. Black clubs, 13. Here, black spades are here 13 cards. 13 cards. So here now, the total, these are total deck of cards. Total deck of cards. See children here, A, 2, 3, 4. You are 13. The first one is what is here? Black clubs. The first row is black club. And second row, watch here, black spades 13. Here first one 13, second one 13. So total black colors how many? Yes, 26. Red color. Here red heart. Red heart. Red heart. 1, 2, 3, 4. Here A. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. J, Q. So here face cards. Face cards J, Q, K are called face cards. Remember children? J, Q, K are face cards. And here last one diamond. Last one diamond. These are also 13 cards. So here 13 plus 13 plus 13 plus 13. Totally how many cards are there in a deck of cards, children? Yes, 52 cards. How many cards? 50. Black in color 26, red in color 26. So totally one suit has 13 cards. Each suit has 13 cards. So totally here 4 suits are there. So 4 suits are there. 13 plus 13 plus 13 plus 13. Totally 52 cards are there in a deck of cards. In a deck of cards. Here once again we remember JQK. JQK are face cards. Totally how many face cards are there? 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. How many? How many face cards are there here? 12. How many A's are there? How many A's? 1, 2, 3, 4. 4 A's. 4 A's. How many 2's are there totally? Here like this. So we divided into which what we want. Okay. Next we go children here. One example is there. See children. An example is there. One card is drawn from a well-shuffled deck of 52 cards. Already we learned. Totally well-shuffled 50 deck of 52 cards. Calculate the probability that the card will one be an ace, not be an ace. So here totally 52 cards are there in a deck of cards. 52 cards are there. Here we calculate the probability. So we recall the classical definition of probability. What is the definition of probability? Yes, P of E is equal to number of favorable outcomes by total number of positive outcomes. Okay. Now the solution is here. Well shuffling and equally likely outcomes. The first one here. There are 4 aces in the deck. Already we know that. There are how many aces are there? 4 aces, 4 aces, 4 jacks, 4 queens. Total 4 are 4. Here also in a deck of cards, total how many A's? Already we saw. Here there are 4 A's in a deck of cards. So let E be the event. The card is an ace. We find out the probability of we pick one of the cards, we pick up one of the cards that it will be ace. What is the probability? Getting an ace. Let E, we indicate E. E be the event, the card is an ace. Let E be the event, the card is an ace. The number of outs favorable to E. Children, we already find it. How many aces are there? 4 aces. So the number of favorable outcomes, how many? 4. Already just we learned the number of possible outcomes. Why? Because we use a formula. Here the number of possible outcomes are how many? 52. How many? 52. Why? Because in a deck of cards, how many cards are there? 52 cards. That's why here we take into the number of possible outcomes are 52. But here, what are the favorable outcomes here? 4. Why? Because only the favorable are only 4 out of 52 cards. Ace favor, only 4. That's why we take a favorable. That's why we take here 4. So recall the formula. What is the formula? Therefore, P of E, probability of E. E means here the card is an ace. E means here the card is an ace. So that P of E, probability of E is equal to probability of the card is an ace is equal favorable number of favorable outcomes divided with total number of possible outcomes. So here 4 by 52 simply. 4 by 52. So here 4 we change into smallest fraction as the smallest fraction. 4 ones are 4 13s are. We change it into smallest fraction. So here 4 ones are 4 13s are. So that's why here the probability is what here? 1 by 13. Probability is what? 1 by 13. So 4 by 52. 4 by 52. The smallest form is 1 by 13. 1 by 13. So this is the probability of it should be getting an ace. Now next one. So here let F be the event, the card drawn is not an ace. See here, F be the event, the card is not an ace. It's not already aces are, how many are aces are there? 4 aces are there. So when we pick up a card, that it should be not an ace. In previous example, we find that it should be ace. Now we find that it should be not ace, not ace. That's why here the number of outcomes favorable to the event. See here, isn't children here? FB event, the card is drawn is not an ace. So the favorable outcomes. So we take 52 minus 4. These 48 are favorable to not an ace. Have you understood? Okay. The number of favorable, 48 favorable outcomes are there. Why? Because here those 48 are not belongs to ace. So they are not an ace, not an ace. So here favorable how many? 48 favorables are there. How many favorable outcomes are there? 48 favorable outcomes. That's why already we find the possible outcomes. Total number of possible outcomes 52. Already we learned the number of possible outcomes 52. That's why so our the formula probability of F. F means not an ace. F means not an ace. Probability of not an ace is equal to 48 by 52. 48 is favorable outcomes. 52 is total possible outcome. That's why 48 divided with 52. So we change into smallest fraction 4 12. 4 12 is 48. 4 13 is 52. 4 1 is 4. 4 2 12 is 4 1 is 4. So 12 by 30 is the probability of getting not an ace. When we pick up a card, the getting is not an ace. Card drawn is not an ace. The probability of card drawn is not an ace is what here? 12 by 30. 12 by 30. Okay, we move to next one. So children, now we will try some more examples. So here, I think you have a single deck of well-shuffled cards. Here, a single deck of well-shuffled cards means. Tell me how many total number of cards are there? Yes, 52. Then we try to find this one. So here, the first one is write down, children. All of you write down these questions. This problem hard. What here? What is the probability that the card drawn will be a queen? So here only single deck of well-shuffled card is there. Single shuffled, well-shuffled single deck of card is there. So here we find out the probability. What is the probability that the card drawn will be queen? Queen. The probability the card drawn will be queen. So simply I will hint for you what is how many favorable outcomes are there? How many favorable to queen? Okay, already. Oh, right. Next, total number of possible how many? Yes, that's why we divided favorable outcomes by possible outcomes. So you must do this one, children. You must write down on your notes and do that some. Next one, children. What is the probability that it is a face card? Already, just we learned about it. Okay, what are the face cards? Already we discussed. How many face cards are there in a deck of cards? Okay. Now, what is the probability that it is a face card? We find so simply already what is the formula? Already we know the favorable outcomes divided with for possible outcomes, total possible outcomes. So the favorable outcomes to face card is how many? Yes, that's right. That is correct. That by total number of positive outcomes is a very easy. So you did this problem. You solved the problem, children. Next, third one. Next, here, what is the probability it is a spade? What is the probability that it is a spade? Already, this is also same. What is the probability for the favorable outcomes by total positive outcomes? How many favorable to spade? How many favorable to spade? Yes, that is divided total number of deck of cards. How many? Already. Okay, this one. Do that one, children. And fourth one is there. What is the probability? What is the probability that it is the face card of spades? So here in third one, total spade. Probability of a total spade. But here face cards of spades. Face cards. So in do identify these difference. Okay. Here in third one, total spade. But here face cards of the spades. How many favorable outcomes to face cards of spades? That's divided with the total number of favorable outcomes. Okay, have understood? Like that. Total number of, so it is the face cards of the spades. So, and next one, children. So, what is the fifth one? What is the probability it is not a face card? It is not a face card. Okay, here what is the probability? Not a face card. Already favorable outcomes, not a face card. Total face cards are how many? You remove. Remaining are favorable. Remaining are favorable. So that's why here the favorable outcomes by total number of positive. See children, using the playing cards, we create so many problems. We create so many problems. Do the children discuss with your friends and create some more problems, and also we discuss the solutions also. Okay, children, solutions also. So these 5 questions are for you children. Please do tomorrow. And now we should see here some useful. The probability. Once again, the use of probability. Children, see children here, use of probability. Already we learned the use of probability. What is the use of probability in our daily life? In our daily, when we use. So once again, we will learn about use of probability. Let us look at some more occasions where probability may be useful, children. In our daily life, so the probability is one of the most important tool. It is useful to us and also in various situations. So we know that in sports, some countries are stronger and other are not so strong. Already in many games or many in sports, we know that some team very strong, some were not strong. We also know that when 2 players are playing, it is not that they win equal times. It's already we know that every team not win every time. Some people it will win or not. That is the rule. And also the probability of winning of the players or team that wins more often is more than the probability of the other player or team. So the probability is depends on the players, the winning players. We estimate so this team will be win. Why? Because the players are very capable like that. So we also discuss and keep track of birthdays also. Sometimes it happens that people we know have the same birthdays. Okay, some birthdays are same. Sometimes it happens. The people that will celebrate same day occasionally. So here, can we find out whether this is a common event? Is it a common event, or would it only happen occasionally? classical probability help us to do this. So is a classical probability. The classical probability help us to do that one. And children, here one more example is there. Listen carefully and see, children, here. Write down in your notebook also. Sangeeta and Reshma. Here two persons are there. Who are Sangeeta and Reshma play a tennis match. Play a tennis match. It is known that the probability of Sangeeta winning the match is 0.62. What is the probability of Reshma winning the match? So here, see children, here two players, Sangeeta and Reshma. So the probability of Sangeeta winning probability. The winning probability of Sangeeta is how much? 0.62. What is the probability of Reshma winning the match? So see children, here, let S be the Sangeeta and R be the Reshma. We denote like that. Shortcut. Let S and R denote the events that Sangeeta win the match and Reshma wins the match respectively. So the probability of Sangeeta winning chances. Here we recall once again. Complementary events. Complementary events. Yes, complementary event is what? P of E plus P of naught is equal to how much? 1. That's right. We take the probability of Sangeeta's winning chances is probability of S is equal to 0.6, which is given 0.62. So here already Sangeeta winning match probability is what here 0.62. That's right. And the probability of Reshma's winning chances. Here P of S plus P of R is equal to 1. P of S plus P of R and P of not S means here P of S, P of R means not S. Okay, here R means not S. So P of E plus P of not E, like that. Okay, P of R is equal to probability of Reshma is equal to 1 minus probability of Sangeeta. 1 minus probability of Sangeeta. So here the probability of winning Sangeeta is 1 minus 0.62 equal to here 2. Here it is 0.38. How much probability of Reshma winning match? Here what here 0.38. Totally 0.62 plus 0.38 is equal to 1. That's why here we take into complementary events. The formula of complementary event. So children, note this example, children. Okay. So here we in this situation we take complementary events. P of E plus P of naught is equal to 1, like that. Okay. Now let's move next one. Example 7. Children, see children here. Write down in your notes. Example 7. What is the example? There are 40 students in 10th class of school, of whom 25 girls and 15 are boys. See children, listen carefully here. Once again I will read it. There are 40 students in class 10th. How many students are there? 40 students are there. How many students are there? 40 students are there. So in 40, among 40, 25 are girls. 25 are girls and remaining 15 are boys. 25 plus 15, 40. Totally 40 students in 10th class, 25 are girls and 15 are boys. And the class teacher has to select one student as a class representative, as a class leader like that. The class teacher has to select one student. If we select one student as a class representative, she writes the name of each student on separate cards. The card being identical. So 40 students' names are written in the separate cards. So 40 cards are there. 40 students' name, 40 cards are each name has in that card. Then she puts card in a box. And she puts in a box and stills them thoroughly. Imogen thoroughly. She well shuffled. She well shuffled cards in a box. She then draws one card from the box. Totally 40 cards are there. Each card contains names of the students. 40 students. In 40 students, 25 girls' name and 15 boys' name on the card. So totally 40 box, 40 cards are in a box. You are well shuffled still thoroughly. And what is the probability that the name written on the card is the name of a girl? If we pick up one card, the probability of getting a girl, we find the probability getting girl. Second one is the probability of a boy. If you pick up a card, that will be name of the boy. So we find see children here. Here there are 40 students are there. How many students are there, children? There are 40 students are there. Already given. There are 40 students are there. Among 40 students, and only one name card has to be chosen. Here we pick up only one card. We choose only one card. The number of all possible outcomes already we know that. Why? Because the total 40 students are there. That's why possible outcomes are 40. Possible outcomes are total possible 40. Why? Because there are totally 40 students are there. That's why we take the number of all possible outcomes is 40. The first one is what here? The number of outcomes favorable for a card with the name of a girl. And the first one is when we pick up a card, that it should be name of the girl. How many favorables are there? How many favorable outcomes? Already we learn. Already given. This is also given. How many total girl names are there? 25. So the number of outcomes favorable for a card with the name of girl 25. Okay, already there. Possible outcome is there and also favorable outcomes. That's why what is the probability? The probability P of E is equal to favorable outcomes divided with all positive outcomes. Okay. Probability is equal to favorable outcomes. Favorable outcomes divided with the all possible outcomes. That's why here P, probability, card with the name of a girl. Card with the name of a girl is P of G. P of girl is equal to simple. Yes, that 25 by 40. This is a favorable 25 divided with 40. Favorable 25 girls. We take 25 because the favorable 25 girls, only 25 girls are there. That's why we take into 25. 40, total 40. 40 students are there. That's why we take into possible, total possible. 25 by 40. So we change into smallest fraction of 5 5s are 25, 5 8s are 40. So the probability is the smallest form, 5 by 8. 5 by 8. This is what is the probability of this? Probability of getting with the name of a girl. Now we go to second one, children. Here. See, children. The number of outcomes, second one. It goes to second one. The number of outcomes favorable for a card with the name of a boy. So here, when we pick up a card, on that card, the boy, it should be boy's name. Any one of the boy's name. That's why the favorable is how many? 15. Why? Because it is given. 15 boys are there. 25 girls are there. 40 totally. So here, that's why. Here, the number of outcomes favorable for a card with the name of boy is how many? 15. How many? 15 boys. Therefore, probability here P. P means probability of card with name of a boy. That is equal to P of boy. Probability of boy. P means probability of a boy is equal to, we recall our formula. What is the formula? Number of favorable outcomes by total number of possible, total number of outcomes. Favorable outcomes divided with the total outcomes. So 15 by 40, simple. 15 by 40. So 15, 5 3s are 5 8s are. 5 3s are 5 8s are. 3 by 8. Have you understood? 3 by 8. So already we find the girl probability and we find the boy probability. Or here we use complementary events. Here we use complementary events formula. So what is that P of E plus P of not E is equal to 1. So P of boy plus P of girl is equal to 1. Girl means not boy. Girl means not boy. Here the probability of boy is equal to 1 minus probability of boy is equal to 1 minus probability of not boy. Not boy means here girl. Yes, not boy means girl. So 1 minus P of girl is equal to 1 minus 5 by already 5 by 8. Already we find it. Okay, 1 minus 5 by 8. So here 8 is LCM. So 8 minus 5, 3 by 8. 3 by 8. So or we find like this, and we use a complementary formula also. Okay, children, please note down in your notebook, children. So this is the one of the example, and children, next children, now we should complete some statement, children. See, children, listen carefully here. Complete the following. Some statements are there. We fulfill it. Okay. So here, children, see, children. Yes. Number 1 is probability of an event E. Okay. Probability of an event E plus probability of an event not E is equal to. Tell me, children, what? Already just we discussed. P of E plus P of not E. Tell me what? Yes, that's correct. Is 1. Note down this. Children. Probability of event and P of E plus P of not E. Simple. This is probability of event not E. Is P of E plus P of not E is 1. Very, very important. Next one. Second one, children, see here. Okay, here. The probability of an event that cannot happen is. Tell me, children, the probability of an event that cannot happen. Yes, that can. What's the probability of an event that cannot happen? Yes, children, that's correct. What is it? 0. So this probability is called what? Impossible problem. Impossible event. If the probability is 0, that is called impossible event. Impossible event. Here the first one is related to complementary events. The second one is impossible event. The probability, when the probability is 0, the event is called what? Yes, impossible event. Next we move third one, children. Right, here, third one. Note down the probability of an event that is certain to happen is. Tell me, children, is that such an event is called. Right down, children, this is the probability of an event that is certain or sure, it happen is what? What is the probability of certain? What is the probability of certain? Yes, that's correct. What, children, what here? Yes, 1. The probability of an event that it is certain to happen is, yes, 1. Such event is called, children. Tell me, what is such event is called? Yes, that's correct. Which event? Sure event. Which event? Sure event. If the probability is 0, impossible event. If the probability is 1, there is a certain event or sure event. Okay? Certain event or sure event. Write down children this. The probability is 1. We call it as sure event. Sure event. Next one children. Next one. Yes, right. The sum of the probabilities of all the elementary events of an experiment is, already we discussed, the sum of all probabilities. The sum of the probabilities, all the elementary events, all the elementary. If we toss a coin, getting a head is how much? 1 by 2. If we toss a coin, getting a tail, 1 by 2. So add these 1 by 2, 1 by 2, how much? 1. Like that, the sum of the probabilities, of all the elementary events in an experiment is what? And so another example is that when we roll the die, what is the when we roll the die, what is the probability of getting 1 on the top is what? 1 by 6. Getting 2, 1 by 6. Getting 3, 1 by 6. Getting 4, 1 by 6. Getting 5, 1 by 6. Getting 6, 1 by 6. So add these all 1 by 6 plus 1 by 6 plus 1 by 6, 6 times. So 6 by 6. 6 by 6 means, yes, here the answer is that one. 1 is the answer. So here the sum of the probabilities, of all the elementary events of an experiment is what here? 1. It's called 1. Next one, see children here. So it's a very important one. What is that? The probability of an event is greater than or equal to and less than or equal to. Already we discussed so many times. The probability is greater than equal to dash, less than or equal to. Yes, you are right. The probability of an event is greater than equal to 0. Greater than or equal to 0. And less than or equal to what? 1. So 0 is less than or equal to P of E less than or equal to 1. Already we discussed. Once again, note down the point. 0 is less than or equal to probability of E. P of E less than or equal to 1. So this is that the probability of an event is greater than or equal to 0 and less than or equal to 1. These are the very, very important points. Please note down on your notebook. Okay, children? Right. Next. Now we learn some children. One of the problem is there. So please note down this one. If P of E is equal to 0.06, probability of an event is equal to what here? 0.06. What is the probability of not E? What is the probability of not E? Okay, by using which formula? Is complementary events. We take into complementary events. So here children here from complementary events, P of E plus P of not E. Here not E, here not E here is equal to 1. P of E, write down children, P of E plus P of not E is equal to 1. So this line is here, P of not E. So the next one, here P of E means 0.06. We substitute the value of P of E. So 0.06 plus P of not E is equal to 1. So P of not E is equal to 1 minus 0.06. 1 minus 0.06. So here 0.94. So this is one of the example. So we find if P of E is given, we find P of not E. If P of not E is given, we find out 3 out. So these are the complementary events. These are the complementary events. So P of naught is how much here? 1 minus is 1.00, 0.06. Here 10 minus 6, 4, and here 9. 9 minus 0, here 9. So 0. So 0.94 is the final answer. P of naught is 0.94. Next one, children. Okay. Another one is there. Another problem is there. Fourth one. What is it? A bag contains lemon flavored candies only. A bag is there. A bag is there. So Malini takes out one candy without looking into the bag. See children here. A bag contains lemon flavored candies. Chocolates. Candies only lemon flavored. Which flavor? Lemon flavored candies only. Malini takes out one candy. She took one candy without looking into the bag. She took one candy. What is the probability that she takes out? Simply we find what is the probability? What is the probability that she takes out? What is the probability? Okay, next here. Number 1, an orange flavored candy. First we find here an orange flavored candy. Second one we find a lemon flavored candy. So here 2 are there. 2 questions are there. A bag contains lemon flavored only. Malini takes out one candy without looking into the bag. What is the probability that she takes out? Number 1 is an orange flavored candy. Second one is a lemon flavored candy. So see children here, lemon flavored candy. So solution. Here solution. Bag contains only lemon flavored candy. This is a given. This is your only bag contains lemon flavored only. The first one is what here? Taking an orange flavored candy is. There is no lemon. Only lemon is there. Orange, there is no orange. Taking an orange flavored candy is an impossible. Why? Because lemon flavored candies are there. Only lemon flavored candies are there in that bag. That's why we find that taking an orange is impossible. Have understood? Taking an orange candy is impossible. Why? Because there is no orange, only lemon out there. That's why here taking an orange flavored candy is an impossible event. Okay, impossible. Okay, recall impossible event probability is what? What is the impossible event probability? 0, like 0. It's not possible. Taking an orange flavored candy is an impossible. Why? Because the bag contains only lemon flavored only. That's why it is not possible. So it is impossible. That's why the probability is what here? 0. Here 0. And second one, children. See children, second one. And also taking a lemon flavored candy is totally lemon candies are there. Totally in the bag contains lemon flavor, totally lemon. We take lemon. So that it should be sure or certain. Okay? That it should be sure or certain. So here, and also taking a lemon flavored candy is certain or sure. Certain or sure. And hence, hence the probability is what, children? Yes, 1. Here the probability of orange flavored candy is 0. The probability of lemon flavored candy is what, children? 1. Because totally lemon candies are there. That's why it is to be sure. In this first situation, there is no orange flavor. There is no orange flavor. If we take, it is not chance. There is no chance. That's why it is impossible. That's why it is impossible. In this second situation, only lemons are there. Totally lemons are there. We take any one, that it must be lemon. That's why the sure event. The probability of sure event is what? 1. So next one, children. Another one. So here, Rahim removes all the cards from the deck of cards. See children here. Another one. Rahim removes in a deck of cards, what is the probability of? See children. Rahim removes all the hearts. He removes all the hearts, red hearts from the deck of cards. What is the probability of? First one. We see here, first one. Getting an ace from the remaining pack. When we pick up a card, we take a card from deck of cards. It should be an ace. What is the probability? See children here. So here. Total number of cards in the deck. How many? Already we know that. What? 52. How many? 52 cards. Total number of hearts are how many deck of cards? Yes. Hearts. Total number of hearts. We find the probability of hearts. How many? Yes. Hearts. Red hearts. 30. So when all hearts are removed here, remaining cards how many? 39. 39. The first hint is here. What is? Totally hearts are removed. Total rounds are removed. Put it aside. The remaining card how many? 39. So here the first one, picking an ace. Here we are picking an ace. Number of outcome favorable to ace is what here? It is equal y and 3. Why? Only there is already red heart. It's removed. That's why diamond ace, spade ace, club ace. Only 3 are there. That's why probability of ace. P of A is equal to number of outcomes by total number of possible outcomes. Okay, children. Here, favorable how many here? Favorable how many? Yes, 3. Why? Because only 3 aces are there. Another, actually 4 aces are there. 4 aces. 1 ace already removed, put it aside. So here remaining 3. And also total hearts are removed. Hearts also 13. 52 minus 30. Only 30. 39 is our total possible outcomes. 39 is total possible outcomes. So here P of A, probability of A is equal to number of favorable outcomes by total number of possible outcomes. That's why here favorable outcomes is how many? 3. Here total possible outcomes 39. Here not 52. Why? Because already we remove heart shapes totally. That's why here 39 is the possible. 39 is the possible. That's why here P of A is equal to 3 by 39. Okay? 3 by 39. 3 1 ja 3, 3 13 ja. So the picking an ace, the probability of picking an ace is what here? 1 by 13. 1 by 13. So here using this we create so many questions, so many problems, children. Using playing cards. There are so many. We create so many problems. So children, this is our end of the class. So tomorrow we will try to do some more problems from our textbook also. Children, I suggest you children, you are also try to create some more problems on this. If any doubts, please discuss your friends, and also you must consult your class teacher. You consult your class and clarify your doubts. So children, this is the end of the third day. Thank you, children.
Thank you very much, Purushottam sir. That is the end of the day 3 probability class. And today, sir has discussed about the playing cards and how many cards are there in each set, and naming of those numbers, and questions solved on the uh, playing cards, and as well as the exercise questions are discussed to you. Tomorrow we'll see at 9 o'clock. Thank you very much for the technical team who is supporting extendedly their services to the 10th class students in online live streaming classes in YouTube. Thank you. See you tomorrow at 9 o'clock.